Welcome to this video on the topic of binary numbers and operations. In this video, we'll be having a look at something called the Bitwise Operations. Now, in mathematics, you'd probably be familiar with the 4 arithmetic operations that you have at your disposal, those being addition, subtraction, multiplication, and division. So when we use these operations with 2 numbers, we get a third subsequent number. Now, all of these operations here, they're available on binary numbers. However, that's not the focus of today's lesson. Rather, what we're focusing on is 4 new operations that we can use. Now, the 4 new operations that we're interested in are the Bitwise NOT operation, the Bitwise AND, the Bitwise OR, and the Bitwise exclusive OR. Now, looking at the symbols underneath here, these symbols, we use them to denote the usage of the operations in something called the C programming language. We're not going to use them today. However, what we are going to use are these word symbols here. So these word symbols here are going to denote an operation we're doing to a number. Now, if we look down below here, I've got a number of examples. What we're going to do is we're going to use these example cases over here to understand the operation and the function of these operators we see here. Now, starting off, we're going to do an example with the NOT operation. What the NOT operation does is it reverses the polarity of the bits within a number. So, if we have a number and it's defined as, A is defined as 0, 1, 1, 0, 1, 0, 1, 0. To perform the NOT operation, what I'm going to do is I'm going to set it at, then I'm going to go in for the NOT operation. So we're setting it at as if we're doing some form of arithmetic involving addition or subtraction. Okay, now we're set up. What we're going to do is we're going to go for the NOT operation. Now the way in which this works is that when we do a NOT or a bitwise NOT on a bit, we're simply going to reverse its polarity. So if it's a 0, it turns to a 1. If it's a 1, it turns to a 0. Consequently, this 0 over here is going to turn into a 1, followed by a 0, 1, 0, 1, 0, 0, and 1. So this writing in blue here, this is the result of our bitwise NOT operation on the value of A. Going down, we have another value B. Let's do the bitwise operation on this as well. Flipping all the bits, thus we're able to see the bitwise NOT operation. Next example, we're looking at the AND operation, the OR operation, and the exclusive OR operation. Now, in all of these examples here, we have 2 values, A and value B. A is defined as 0, 1, 1, 0, 1, 0, 1, 0, and B is defined as 0, 1, 0, 1, 1, 1, 0, 0. In example A here, we're going to do a bitwise operation of ANDing A and B together. To set this up, I'm going to set it up like it's arithmetic. So I'm going to write first the value of A. Notice how I'm using the grids on my paper. Reason being is that it's going to allow me to align all of the numbers together so it's easier to read and thus easier to follow. I highly recommend, if you have grid paper, to align it in this sort of arrangement as seen here. Now, setting it up, we're going for a bitwise AND operation. Alrighty. Now, the way in which a bitwise AND operation works is that for a value to be a value of 1, both of the bits have to be equal to 1. So over here, if we have 0, 0, the value of that, because they're both 0, is going to be 0. So it's 0 and 0 is equal to 0. The next one along, 1 and 0, is still equal to 0, because they both have to be active. 0 and 1 is going to be equal to 0. But 1 and 1, so here, that's where we get the first case of being 1. Moving along, 0, 1 is 0, 1, 0 is 0, 1 and 1 is equal to 1, and 0 and 0 is equal to 0. So example A. Now going down to example B, we have a similar situation. We're going B and A. So setting this up like before, there's my B, here is my A, and we're going for a bitwise AND once again. Now the difference between the example A and the example B is such that the roles of A and B in this operation here have been reversed. However, what we find is that the outcome of the result is unchanged because 0 and 0 is 0, 0, 1 is 0, 1, 0 is 0, 1 and 1 is both 1, 1 and 0 is 0, 0, 1 is 0, 1 and 1 is 1, and 0, 0 is simply 0. So what we find is that order is not important, as the result is both the same between A and B and A. Going down, we have the bitwise OR operation. Now, once again, I'm going to set these out as if I was doing it like the first one. Finishing off the setup. Okay, now we're good to go. Now, doing this, the way in which the bitwise OR operation works is such that if any value or if any bit that's been ORed together is a value of 1, then the result is going to be 1. So looking at the first two numbers, or the first two bits, we have 0, 0. Because both of them are 0, the result is 0. But moving along to the second row of bits, the second column of bits, we have a 1 and a 0. Because this 1 is active, then the result is going to be active. Similarly, we have 0 or 1. Because the 1 is active, everything's active. Similarly, on the fourth column, 1 or 1 is going to be 1, 1, 1, 1, and then we get back to the case where neither are active. As a result, it's going to be 0. So with the bitwise OR operation, so long as one of the bits in the operation is equal to 1, then everything is 1. Alright, moving along. We're presented with the exclusive OR operation here. So we're going A exclusively ORed with B. What I'm going to do is I'm going to set this arithmetic up like examples in A, B, C, or A, B, and C. So our value for A is going to be 0, 1, 1, 0. Now, the way in which this exclusive OR operates is such that you receive a value of 0 if both of the values are the same. So if you have a 0, 0 or a 1 and 1, your output will be 0. However, if only one of the bits is equal to 1, then you're going to get an output of 1. So because we've got 1, 0 or 0, 1, you're going to have an output of 1 there. So applying this rule for the first bit, we have 0, 0 because they're both 0. The output's 0. The second column, we have 1, 0 because this guy is active. That means that that's going to be on. Furthermore, 0, 1, there's a 1 there, so that's on. 1, 1, this is where it gets different. Because they're both active, then we get an output of 0. So it's got to be either this or this, not both. Next one along, we get 1, 1, 0, 0. So this is the exclusive OR. Only one bit is active to have an output of 1. And now we go down to our final and most tricky example. We've got not A and B exclusively ORed with A. Now we're going to use rules similar to the rules of BEDMAS in that firstly we're going to take care of the brackets. So we're going to go this A and B. Then we do the bitwise NOT because it operates directly on a single value. And then we're going to carry out the exclusive OR. Now carrying this out, we're going to go A and B. The values of A and B, 0, 0, 0, 1, 0, 0, 1, 0. From there, we're going to go for a bitwise NOT operation. This is going to yield a result of, and then finally going for a exclusive OR operation, putting in the value for A again. This will yield a value of 1, 0, 1, 1, 1, 0, 1, 1. And thus this will be our result. So first step is to define the order of operations. Rather than define, it should be identify. And then we're going to carry out operations in sequential manner. Now, in summary, what we had a look at in this particular video was we reminded ourselves of the 4 operations that you might use in mathematics and how we will eventually be learning how to use them in binary. And then our focus today was focusing on these 4 bitwise operations here. So the bitwise not, bitwise and, bitwise or, and bitwise exclusive or. From there, we did a few practice questions so we could learn how the operations actually work. What I recommend from here is underneath these notes here, there's a few practice questions. I recommend you have a go at some of those to ensure that you're able to do these particular operations here.